Okay, yes. So, hi everyone. Today we are very pleased to have Carlos Mendes. Something is not working. Technical. Feeling like
So, okay. Fix that really quick. Zoom. No, it's hidden. Second. Sorry. Look. Okay. Where is? Sorry, his Zoom controls keep disappearing. Here, I'm gonna try and get out of your way so I can fix this. Go ahead.
yeah.
Yeah.
Is that okay?
Yeah.
Okay. Sorry everyone, we had some technical difficulties, but now we even have a fuller room, so was for the best. So hello. Today we are very pleased to have Carlos Pérez, the Yale Institute for Biospheric Studies Edward Bass Distinguished Visiting Environmental Scholar, who will be giving a talk on how sustainable use of forest reserves catalyze enhanced livelihoods in rural Amazonia. In case this is your first BIOMES, over the last 15 years, the Yale School of the Environment has held this weekly seminar series, which we named BIOMES, and which has been the school's flagship forum for bringing cutting-edge research and impactful work to the community. BIOMES stands for Bridging Issues and Optimizing Methods in Environmental Studies. In this vein, we're excited to introduce Carlos Pérez, Professor of Conservation Ecology at the University of East Anglia in the UK, and co-founder and science director of Instituto Juruá, an Amazonian non-profit conservation NGO that has been successfully implementing community-based conservation for over a decade. Carlos was born and raised in the eastern Amazon, and for the last 40 years, he has been studying wildlife community ecology in Amazonian forests, the population ecology of key neotropical forest resource populations, the biological criteria for designing tropical protected areas, and community-based integrated conservation development. He also serves as a policy advisor to the Ministry of Environment of Brazil on a range of conservation and development issues in the Amazon. Please join me in welcoming Carlos Pérez to the stage.
Are we good to go?
Yep.
No idea. Okay. Okay, that's great. How do we start this? Okay. Excellent. So thank you for the invite and Patricia, the introduction. Before we start, looking forward to telling you everything about conservation people in the Amazon, but that's just a joke. This is April's Fool's Day. I'm actually going to be talking much more specifically about community-based conservation, community-based resource management. And I'll start a little bit of the sort of the background, and then I'll go into a case study, successful case study that we've implemented in the Western Brazilian Amazon. So just crash course in the Amazon in 30 seconds. So that's about 7.4 million square kilometers. So it's over half of the world's remaining tropical forest. If you just take the Brazilian Amazon, which is 3/5 of the whole thing, that's 413 states of Connecticut. Okay, so that's a big piece of real estate to look after. And you can't look after that, you know, if you're stationed in a big city somewhere. And most landscapes in the Amazon, they kind of look like this, and there is no such thing as an entirely unoccupied landscape. There are people everywhere, albeit often in low population densities, but we have local communities, indigenous peoples, that are populating this region. In fact, the whole rural population of the whole Amazon is about 34 million folks. You could argue that they are the legitimate guardians of that territory. And the other thing is that, you have a lot of protected areas. Something like 40% of the whole Amazon is protected on paper, but there's no such thing as a protected area that is entirely free of people. That people are everywhere. In fact, if you look at the evolution of protected areas in the world, in Brazil, and in the Amazon, sustainable use reserves, they overtook strictly protected reserves a long time ago. So they're much more justified politically, and therefore a much easier sell, if you like. So most reserves, if you go to the Brazilian Amazon, it's huge number of reserves, total acreage. They're going to be extractive reserves, sustainable development reserves, national forests where people log, state extractive reserves, and so forth. And of course, the indigenous reserves, which amount to 21% of the Brazilian Amazon. The other thing is that, obviously, if you're talking about protecting intact biotas in perpetuity, protected areas are absolutely essential, but they're not enough. So, for example, the hydrological thresholds in the Amazon alone will dictate that if you just protect those 40%, many of these areas will actually burn because of hydrological failure, forest flammability, essentially fires, wildfires understand no boundaries, and many of these protected areas will burn if they're not within some sort of basin-wide hydrological threshold. So what we're talking about are, if you look at the whole gradient of human disturbance, anthropogenic disturbance, we're talking about, don't know if this works, these areas here, these areas that are either completely intact or relatively intact. So forest cover, you got that sort of beautiful closed canopy forest, and it's still filtering, 98.5% of all the light that hits through the canopy. So we're talking about those scenarios there, and ideally we want to keep as much of the Amazon into these classes. Now, the other thing is that, people for a long time, since the 50s really, have been trying to help set up these conservation development projects. You might want to call them integrated conservation development programs or ICDPs. The problem is that when you run through those, I've studied the whole history of these programs by multilateral agencies, banks, bilateral agencies. So, for example, the World Bank alone poured $3.5 trillion into these projects since 1980. And the problem is that trade-offs dominate the outcomes of all of these projects. They're rarely win-win. They rarely generate co-benefits, okay? So think about projects that might generate environmental gains, conservation gains, and projects that might generate social, environmental gain, economic gains, okay? But hitting the sweet spot, if you like, of doing all three is really, really difficult. And all the experience and billions of dollars that have gone into this prove this right, okay? So most of these ICDPs only succeed on one of those dimensions, or neither. And why are they so rare? Why are these win-wins so rare? Well, you know, there's a whole bunch of reasons. I just want you to focus on just two concepts because we have to move on. The first is opportunity cost. You know, obviously, you're restraining what people can do with the land, yeah? So you're restricting, placing restrictions on land use, resource use. That can aggravate poverty. But on the other hand, you are generating perverse subsidies because you're putting money into people's pockets. That can backfire because they can now afford to buy chainsaws or rent bulldozers, increase agriculture, etc. And that will eventually degrade ecosystems. And this is basically what's been happening. For example, if you look at the Fundo Amazônia, the Amazon Fund program, it's full of these perverse subsidies because they're basically lying in the pockets of cattle ranchers. So how do we do all this? How do we, you know, in this fantasy world, how do we combine all of those things into a single integrated conservation development project? And that means that's a tall order because you have to protect the integrity of natural ecosystems. You have to allow people to improve their livelihoods. All of these economic benefits here provide market access, you know, access to the information economy. Also, all sorts of social benefits like enhanced food security, human nutrition, human health, happiness, why not? Okay, so that's a tall order, and very, very few projects out of thousands of these projects that have happened in the tropics, particularly developing tropical countries, have actually done this. So my neck of the woods is the Amazon, and I've worked in most of the Amazon, over 180 sites. But we also have these long-term study landscapes. For today, I'm only going to be talking about this one here. This is the Juruá River. You hear me talking about the Juruá. But when you think about the Amazon, if you take a Uber taxi in New Haven, that's what's in his mind or her mind, okay? She's thinking about deforestation, the taxi driver, and soon enough the conversation gets to deforestation and, okay, how bad things are and so forth. And that's true. That's, you know, that's largely true. And we have 1/5 of the Amazon already like that, outright conversion into pastures and croplands, but also a lot of the remaining forest cover is becoming increasingly degraded, okay? So think about 1970, when I was 7 years old in Belém, gateway to the Amazon in northern Brazil. This is when I actually started paying attention to these kinds of things. I was just a little kid. Then 1% of the Brazilian Amazon had been deforested, and it's basically this area here where my mother comes from, the Zona Bragantina, okay? Now, if you fast forward to now, obviously, there's been a huge amount of deforestation, the eastern, southern flanks of the Amazon, seasonally dry parts of the Amazon. Much of that deforestation is actually due to the livestock sector. So bovine cattle and bovine pastures account for 83% of all deforestation in the Amazon over the historical record. Okay, and we'll talk a little bit more about that because that involves animal protein, which is essentially what I'm talking about. However, most of the Amazon, if you bother to fly all over the Amazon, actually looks like this, you know? So it doesn't look like the deforested landscapes where many people are funded to work. It's places like this that may look fine, but they still require proper resource management, whether that is an agency or community-based, etc. So all may not be well when you fly over this little green carpet. Looks beautiful. Much of that green carpet is actually occupied by extractivists, but these extractive activities, whether they're harvesting non-timber forest products, game, fish, etc., relatively benign, way more benign than any of the alternatives or the predatory forms of land use. Okay? So, people here are beginning to become not the problem, but part of the solution, okay? And a lot of the things that I'm talking about essentially comes from Instituto Juruá, which we co-founded. So João played a huge role. He was my former PhD student in the Juruá, and we started talking. So now it's a pretty decently established organization, nonprofit conservation organization. We've won several international awards. So everything that I'm talking about here, it's not me, it's we, it's the royal we, if you like. Just to demonstrate that this is not a blind sleepwalking exercise. We didn't just start this thing. We tried to plan things over so there is method to this madness. So you need to think about the partnerships, what you want to achieve, the enablers, and the best expected outcomes, what you're expecting to get out of the whole thing, right? So these expected outcomes that you see here, but you need all of those things here, so it's a complicated flow chart. You need to think through those steps rather than just marching blindly forward. So we're talking about the Juruá Basin, which is a relatively small river basin. What we do now, we do basin-wide conservation within that basin. So the Juruá has a favorable scenario. There's only about less than 1 person per square kilometer. Obviously, that helps. So these are the different, there's been relatively little deforestation. This is the situation with protected areas, most of which are sustainable development areas, not strictly protected. The one exception is this national park here, Serra do Divisor, where we've also worked. But most of these places are indigenous reserves and sustainable development reserves, okay? And the interesting thing about the Juruá is that if you actually measure how rivers behave all over the world, it's actually one of the most meandering rivers in the world. And that's actually really good news for floodplain productivity. The geomorphological complexity of these floodplains are just completely exceptional. So I'm going to zoom in to what the Juruá looks like so that you can see all the oxbows and the river lateral channel migration. Some of these channels are actually moving 50 meters sideways in 1 year. So it's an extremely dynamic system, okay? And if you stretch all of those meanders, just within Brazil, the Juruá is 3,500 kilometers, okay? Which makes it longer than the Mississippi. And yet, it's a small river in the Amazon, right? It's a relatively small river basin. There are at least 12 river basins in the Amazon that are bigger than the Juruá Basin. And it's important to understand that, that Andean outwash that happens every year creates a seasonally flooded forest. So you can see that community here in the dry season. That's what it looks like in the wet season, in the rainy season. And this is a sustained flood pulse. Unlike your flash floods in parts of the Mississippi, for example, that flood pulse is sustained for half of the year, 6 months. So these forests are underwater for 6 months, okay? And that breaks away all the lack of connectivity between oxbow lakes and fish move around. There's a lot happening during that prolonged flood pulse. And this is just to show that these river meanders are moving every year. This is all the geomorphology of these floodplains. And it's also important to think that these floodplains, they interact with the upland forests adjacent to it, the Tehafimi forests, the non-flooded forests, these areas in green. So essentially you have staggered seed production, fruit production. So frugivores, basically, or granivores, seed predators, they move between the upland forest and the floodplain. So there's a huge amount of seasonal dynamics that's going on. It's all part of the system. And remember that floodplain is seasonally fertilized every single year for the last 30 million years by a layer of alluvial sediments about this thick. And one of the consequences of that fertilization, of that productivity, is fish, okay? So fish biomass is huge. So people, for example, on average, in the Juruá, they consume something like 300, 400 grams of fish every day. That's men, women, and children. The average for the Amazon is 220 grams for people who live by the river or a lake, riverine communities, riparian communities. So it's a huge amount of fish, way bigger than the Japanese population. If you look at the country level fish consumption, Japan comes first. This is double the Japanese consumption, per capita consumption per day. This is important because animal protein is by far the critical component of human diets in the Amazon. If they don't have fish, if they don't have something else, they will go for bovine meat. They'll go for red meat. The problem with red meat is that you need pasture expansion. And as I said before, 83% of all Amazonian deforestation has been caused by pasture, conversion into pasture. Never mind all the greenhouse gas emissions, not just from deforestation, but enteric digestion from cattle. So, if you want to get 1 kilogram of bovine meat from the Amazon, you've already generated 270 kilograms of greenhouse gases equivalents. So the trick here is, how the hell do you manage these floodplains to meet that gap? Okay, to supply the market with carbon neutral animal protein, clean animal protein, but it's also an animal protein that tastes good. We're not talking about aquaculture. We're not talking about fish farming. We're talking about fish, in the case of Arapaima, for example, that actually preys on 130 other species of fish. That's why if you go to the shops here and you buy a pound of salmon from indigenous folks in Alaska, these are wild caught, that's going to cost what? 4 times more than salmon raised in Chile or Scotland. Okay, so this is tasty fish, but it's also really healthy fish, okay? And one of the protagonists of all this is Arapaima. So Arapaima is the largest scaled freshwater fish that has graced the earth, at least extant. We're not talking about extinct fish, right? We had bigger extinct fish. And the reason Arapaima is the way it is because of the Pebas Lake, which flooded 1/3 of the Amazon for 12 million years. And these guys actually developed air breathing because it was a hypoxic lake. It was a lake bigger than the whole of the Mississippi Basin, okay? Lots of critters in the Amazon evolved in the Pebas Lake, massive lake. And this is one of our guys from the community of Chibawazinho carrying one of the arapaimas during the harvest season. So we work along about 1,500 kilometers of that river, not as the crow flies, but if you stretch the meanders, okay? So it takes a long time to get from A to B in this study area. It's possibly the largest study area in the tropics. And then you have a whole bunch of historically overexploited species. The juruá was very much the scenario for the heyday of the rubber boom. Rubber production in the juruá was huge. So once upon a time, there was very dense population, and they clobbered a lot of those harvest-sensitive, commercially important species. Lots of them, including things like arapaima and giant Amazon turtles, Poroconemus espansa. I used to play with these things when I was a kid, and actually hop on top of it and ride. So it's important to think about the conservation of these culturally important species. We tried to coin this term in a paper, and that's far more than just food, right? So it's everything. It's reinforcing cultural identity and all kinds of things. So these culturally important species are hugely important, and it's relatively easy to switch the right buttons when you're talking to people about these important resources. So let's think a little bit about how the community-based arapaima management works in the juruá. One of the things here to note is that these local communities that participate in the program, they build a little floating house at a strategic access point to the lakes, and they guard that lake 24/7 during the whole of the critical season, right? When the lakes become, very easy prey for commercial fisheries, commercial fishing boats. And they're essentially guarding those lakes all the time. And they're doing this out of their own back. Okay, nobody's actually paying them to do this. So there's a huge amount of benefits that they're providing free of charge. Of course, they are the unsung heroes of this whole story. And there are lots and lots of lakes. So for example, at the moment, we manage something like 120 lakes across maybe 80 different communities. And the tricky thing to do, and this took a very long time, thanks to folks at the Instituto Juruá, is that they met with everybody, all the stakeholders and all the commercial fishermen. And eventually, this took like 11 years to do, right? Because you have to convert the most cynical, the most suspicious people about what you're trying to do. So some of these lakes are all zoned. There are 3 categories of lake that are strictly protected lakes where people can only harvest arapaima for 1 week of the year. There's subsistence lakes, which are free to harvest all year round by the local communities. And there are these open access lakes, which are still open to the commercial fisheries, commercial fishing boats. And these guys, they'll come in with their 300-meter gill nets, and they'll whack that lake in a few hours in the middle of the night. Okay, they'll completely clobber the lake, and they'll take everything. But that's okay. That's okay, because those other lakes are doing the source sink dynamics in the system to replenish those highly depleted lakes. And this is basically what happens. So I think I've got a little video here. So if you have a lake that is far into the floodplain, they're very difficult to get to. They are naturally protected. But even accessible lakes, very accessible lakes, can be guarded by local communities. Okay, so the whole thing here is enforcing and maintaining that local enforcement 24/7 by the local community. And these guys are incredibly skillful guardians because, for example, if they hear a motorized boat at 2:30 in the morning, they know that there is a boat, but they also know who it is. Okay, they know if it's a boat that's not one of their boats. Okay, and you can't buy that kind of enforcement anywhere, not even here in the US. Okay, so, and this is basically what happens to these lakes. If you look at the Arapaima, these data are already getting a little bit old in the teeth, but you can see the difference in Arapaima population sizes of just adults, because fishermen, we actually go through this every year. They count every Arapaima, juveniles and adults, in every single lake. And the reason that's possible is because Arapaima is air breathing. If you keep an Arapaima underwater for half an hour, it will actually drown. Some humans have a better capacity to stay underwater than Arapaima does. And that allows people to come and count the fish, just like you count salmon in these shallow streams out west, okay? So we have population sizes, adults and juveniles, every year over many years in every one of those lakes. And that is why we can say that open access lakes are completely depleted. Subsistence lakes are intermediate. Protected lakes do much, much better. And as soon as you protect these lakes, population size keeps growing. It's a bit like you placing $1,000 in the bank, and then you go over there next year, and there's like, $5,000. It's a huge interest rate. The interest rate that this resource gives you is incomparable to any sort of market option that you can choose. And if it's a productive lake, like a whitewater lake, that populations go up even faster. And of course, that amounts to revenues, local revenues. These communities previously didn't know the side of money. Many of these communities, they didn't know what money was. So if a community earns, let's say, $20,000 from that harvest, that one-off windfall harvest, and they sell sustainably harvested fish to the proper markets, they're making a relatively large amount of money per household. We've also worked out, given the population, the intrinsic rate of population growth of Arapaima, with all the little fry that they protect, and males do a lot of that parental care. They are sort of weird fish, right? It takes about, maybe 8 years for the population to hit carrying capacity. That's what K is. K is the carrying capacity of a population in an ecosystem. So if you can wait 8 years, you've got the maximum number of Arapaimas that can fit into that lake. And if you do that, it completely changes the food web of the lakes, because it's not just Arapaima recovering, all the other apex predators are also recovering. So the giant otters are recovering, the black caimans, we have black caimans in the Juruá, they get up to 6 meters, that's 20 feet. And every now and then, somebody goes missing because black caimans gobble people up. All the other apex predators are recovering, and because of that, big fish are hammering medium-sized fish. You basically go through food web dynamics, and eventually it actually increases the productivity of phytoplankton. Okay, so it has huge benefits, not just in terms of Arapaima, but the whole trophic structure of that lake. And it also has this umbrella effect. There's all sorts of incidental consequences to non-target species. So for example, in these managed lakes, you have much larger populations of Espansa, the giant turtles, Uniphilis, which is a little bit smaller, black caimans, and then These are Isa Porocnemis tuberculata, which is a tiny turtle. So the Porocnemis complex in the Amazon is like you've got a turtle this big, one this big, and one this big, okay? So it's a size-graded complex that was filtered down through evolution. And these Porocnemis espansa, which have been clubbered almost everywhere in the Amazon, they require really nice beaches to do the egg laying, okay? And they're very picky, very choosy about those beaches. Those are fluvial beaches. They're sort of beautiful white sand. You can go and even sell it as a sunny spot for your vacation. And the turtles, they need protected nesting beaches if you're going to see all the hatchlings coming through. Okay? And we have people that have protected a handful of beaches, like 14 beaches within our study area to be precise. So that's what one of these beaches look like. This is Mr. Bomba, a friend of ours. He protects one of those beaches. Okay? And if everything goes well and you protect those beaches properly during the egg laying season, you get lots of hatchlings. So we released over 1 million hatchlings into the river. Of course, mortality, hatchling mortality, natural mortality is high, but these things are like any demographic filter. You have to get a lot of hatchlings to get more survivors down the line. So if you look at within our study areas, there's 201 river beaches. Only 15 of those are protected. So we did this nice little experiment. We compared a protected beach against another beach, which is very close by, a very similar beach that remains unprotected. So it's a pairwise design, right? So pairwise design. So if you like your stats, you know that that's a really robust design because there's no confounding effects. And essentially, in the protected beaches, the populations of Porocnemis espansa recover very fast. They do very, very well. And let's see here. This is what the hatchlings look like when they're coming in. The females are actually calling the hatchlings with ultrasound. They're sort of communicating with the hatchlings, even as they are inside the eggs. Much like I think that Tyrannosaurus Rex, T-Rex did that. You get T-Rex here in the Peabody Museum. So these large reptiles, they have this funny way of communicating with their own progeny, even before they hatch. So these are really essential ingredients of the Amazonian aquatic megafauna. And these turtles, the females, that once they lay the eggs, they don't go anywhere. They stay and they wait for those hatchlings because they have to lead them to a safe site after the hatchlings get to the water. So there are incidental effects on non-target species. So back to the pairwise design where we looked at those 14 pairs of unprotected beaches. This is basically what happens in the protected beaches. The ones in yellow box plots here. The turtles are doing much better. The migrant birds are doing much better. Iguanas, almost everything you measure is doing much better. Even insects on the beach, because you have much more necromass, you have more vultures, you have more wildlife. If you do camera trapping, you get lots more animals on those protected beaches. It's a very big difference. A protected beach is full of noises. An unprotected beach, you get deafening silence, okay? And the same goes for other things. So, for example, we took sonars into kayaks in front of those beaches to measure how much underwater megafaunal activity is going to, how many clucks. So, for example, large catfish, they do these clucks underwater. So you can actually measure a relative abundance of these large catfish. Sirenians, we have 2 species of dolphins, gray dolphins and pink dolphins. they do much, much better right next or right in front of these protected beaches. Okay? And these protected beaches are really important for migrant birds because these migrant birds, they come from thousands of kilometers away to nest on those beaches. And that's what they need to do. They need to find protected beaches in order to do their thing. So protected beaches are really important. And I'm just going to summarize this here. This is what happens to an unprotected beach. Completely empty, deafening silence that I talked about. If you protect it long enough and you're patient, eventually some of the females will find their way there and they'll start egg laying, and that will attract more females. Eventually, I don't know if you can hear it. Those beaches become incredibly noisy. Like in some of those beaches, you could be trying to talk to somebody right next to you and they can't hear you, okay? So it's completely different. It's a bit like the difference between night and day. And that's what basically happens eventually in these protected beaches. They become huge foci, huge oases for wildlife. And this whole process that I'm talking about also protects all sorts of other species that have been historically overexploited, including arboreal species, terrestrial species, and aquatic species. So I'm going to show you what basically happened. This is an expedition that we did. And this is the perception from local people, how well the wildlife is doing. So we asked specific questions about specific species, what the status of those species is. So this is a perception study. And essentially this is what happens. In these protected areas, all of these populations, that's what they are. These are all the species here by their vernacular names, okay? So we ask questions about all of those terrestrial species, all of those aquatic species here, black caimans, giant otter, manatee, arapaima. These are tambaquis. This is giant turtles, and both species of cetaceans, the red dolphin and the pink dolphin and the gray dolphin. And they all do much, much better in these protected areas. But they do this over all that access, 1,500 kilometers of rivers. Even in areas that are not protected, these things are coming back thanks to source-sink dynamics in the system. And that also matches the template of how these communities are being empowered. So these empowered communities are doing much better in terms of protection. They're also doing much better socioeconomically, as you shall see in a second. So you can ask, okay, you've got all these conservation gains, so what's in it for us? Why should we do this? Well, that's the reason. So for example, Brazil has had this huge rural exodus problem. Ever since I was a little kid, I hear about people moving from rural areas to urban settings where they're completely unqualified for the urban job market. Well, that process reverses that. That's the most important demographic dynamic in the whole of Brazil, in many Latin American countries, okay? But they also do much better in terms of production flow, sanitation, primary school, high school, healthcare, the way they trade, communication, internet, electrification, electricity, things that you guys take for granted, but is unavailable for the vast majority of these local communities in the Amazon, okay? And if you look at, the difference between communities that are in the program and communities that are outside, you can see that these arrows are all pointing to communities inside. So primary school, market access, transportation of produce, communication, high school, lighting, healthcare, sanitation, those kinds of things. Okay? So these communities are doing better. They are having to work fewer hours in a week. They spend more time with their families. They are healthier and they're happier. They're also earning more money, and a lot of that money goes into the pockets of women. So you address those gender inequalities, the historical gender inequalities, and eventually it goes into the welfare of kids as well. But most importantly, these communities are helping to protect this huge area, okay? So this is a paper that came out a few months ago, it was late last year, that basically shows that in protecting those Arapaima lakes, the Arapaima management lakes, so maybe a community will have 3 lakes that they protect, right? So if you add up the aggregate area of all those lakes, they end up protecting an area 86 times larger than the aggregate area of the community lakes that they manage. So if you think about this, these are the scales of protection, because they're also guarding the entrance to those forests, including the upland forests. And at the moment, all of this protection doesn't cost anything to government. Nobody's paying for this other than the efforts of these local communities. So there's a huge opportunity cost that's basically built into this. It's inherently unfair because they are spending a huge amount of time protecting habitat that, not just basically have different scales of benefits from regional to national and eventually global benefits that they're protecting. So for example, this program in the state of Amazonas alone, that's the state of Amazonas here, is already protecting 15 million hectares of floodplain forest. And this is not protection, this is not governmental protection, no governmental agency is involved, in the sense that this is all done on the back of local enforcement of those access rights. So you can ask the question, and this is an age-old question in social sciences. People in social sciences that work in conservation. What's in it for us? In other words, can protected areas sustain both people and nature? And I would say definitely yes, but it's a maybe yes, because this is context dependent. And these low population density scenarios where opportunity costs are low in general, that can really work. Also, you can see the full recovery trajectory of the entire Amazonian aquatic megafauna. Yeah, all of those big protagonists here. These guys are going through the roof as we speak. So they're doing much better, but people are also doing much better. And that's the rare thing about these programs. So these are the integrated conservation development program outcomes associated with this project. You have this long list of things here. I don't need to read it. But basically, you have a whole bunch of socioeconomic benefits here and a whole bunch of conservation environmental benefits. Yeah? If you're a conservation biologist interested in wildlife, the really important one are these first two. So you get the integrity of these ecosystems, largely intact, and much larger populations of all of those historically overexploited aquatic and terrestrial species. And both of those programs are growing. They are, in some ways, they're spreading like wildfire because there are local benefits to be understood. So for example, if you think about the Arapaima program, it's already in all of those areas. Some of that is sponsored by government agencies. However, most of it is on the back of people who have very little income to begin with. So just going back to our little drawing in the beginning, can you do all three of these things? Yes, you can. But then you also have to think about the cost of that intervention, the financial cost, personnel cost, time, political costs. All of those things are relatively cheap, relatively inexpensive in this case. So we've compared, for example, the cost of conservation in monetary terms of community-based management against all other possibilities. And they always come up to be not just the most effective, but also the cheapest. Okay, so it's a very, that's why your US dollar is going down there. Okay, so in terms of what the Instituto Juruá is doing, these are the kind of like the mission statement things that we'd like to scale up. So of course, I like to protect the high quality applied science, but you've got all of those things here, which are essentially sustainable development objectives that are highly sought after by these development agencies. And yet, we don't, so far, we've never worked with big money in any of this. And it's important to note that of all the sustainable development goals from the UN, the United Nations, we're hitting a good chunk of them, okay? So there's a very good alignment with all the politically correct sustainable development goals that people preach all over the world in these in multilateral summits and everything else. We were at COP30 in Berlin, for example, a few months ago, talking about this, and that's all they were essentially talking about. Okay, so this is all I was going to say. I would just like to thank our local partners. We are not doing this on our own, of course. There's input from all of these agencies, but also input from all of those funders. Thank you.
All right, I think we have time for one quick question. Come on, take it. Yep.
Thanks, Carlos. Considering that the Oxbow Lakes and the rivers are kind of separated at the driest parts of the year, I'm wondering if there's like an understanding of the differences in diversity or in trophic structure of those communities, and would you consider them separate? I mean, obviously they're going to have some shared, but I'm wondering if there's any marked differences between the two.
Yeah, the seasonal dynamic of fluvial connectivity, hydrological connectivity is huge. But we are doing exactly what you're saying. So we've sampled the fish fauna, the ichthyofauna, in all sorts of lakes across those 4 categories, but then also physical access from the river, including those oxbow lakes that are way off. They're old lakes, they're way off the current river channel. So if you go back maybe 400 years, that river channel was there. That river channel has now migrated about 15, 20 kilometers this way. And you can do that either by sampling fish or sampling fish eDNA. We don't have results for that, but most of the difference is in the size structure of the fish assemblage. Not so much in the diversity, but the size structure is huge because essentially every commercially important fish species, the big fish, the large-bodied fish, are no longer with us in these open access lakes. Yeah.
Well, if anyone has further questions, we do have coffee and some snacks downstairs if you'd like to join us and Carlos for more conversation. But if not, thank you for joining us.
Thank you.